Hello geometry students, this is Mrs. Hefty here. We're covering section 2-3 today, which is on conditional statements. Conditional statements are statements that we write in if-then form, and those conditional statements will be true statements. If this happens, then this will happen. The if part of that conditional statement is called the hypothesis, and it's the part behind the if. Do not include the if. The conclusion is the then part of the conditional statement, and again, that's the stuff behind the then. Do not include the word then. So let's take a look at our example in our notes. It says identify the hypothesis and the conclusion for each conditional statement. I only have one in your notes, and it says if it is Saturday, then there is no school. And so we need to identify the hypothesis and we need to identify the conclusion. The hypothesis will be the part after the if. It is Saturday. Now, this is not a very long sentence. It's easy for me to write all of that out. In your homework, you can do that as well. You can write it all out. You should have plenty of time during the hour to work on that. The conclusion is the then part. However, no then, so there is no school. Do you notice here, people, on Saturdays we don't have school, so this if-then statement is a true statement. Again, conditional statements are going to be true statements, and this is a true statement. All right, our next section says, okay, now we need to write each statement in if-then form. So I already have them written out, but I need these to be true statements. So number 2 says, all apes love bananas. So I wrote it two ways here. Let me cover it up here. I can't find my screen cover. Here it is. There we go. All apes love bananas. So first I wrote, if the animal is an ape, then it loves bananas. So I identified my two parts here. I have apes and I have love bananas. So first I've written, if the animal is an ape, then it loves bananas. The other way it can be written is, if the animal loves bananas, then it is an ape. Now the if-then statements have to be true statements. So when you read both of those, oh, not every animal that loves bananas is an ape. I like bananas a lot. I eat a banana almost every day. I am not an ape. So this is not your correct answer. If the animal is an ape, then it loves bananas is the correct if-then statement. Now, I do also notice that apes is first, and it is the if part, and bananas is second, and it is the then part. And yes, that possibly can happen all the time, but not necessarily. Now, if both of them are true, then that's the way I'm going to go. Let's take a look at number 3. The sum of the measures of complementary angles is 90. So what I'm seeing here is I have complementary angles and I have the sum 90. So if two angles are complementary, then their sum is 90. Or I could have, if the sum of the angles is 90, then they are complementary. In this example, you have the complementary angles, and then you're going to be adding them together. So you're going to have complementary angles, and then you're going to be adding them together. So This first one is my answer. The second one is not. You have complementary angles. The sum of the measures of the complementary angles is 90. You have complementary angles first. You're doing the sum second. So the top one is correct. If two angles are complementary, then their sum is 90. On the next problem, you have collinear points lie in the same plane. You have collinear points, and you have them lying in the same plane. So those are the two pieces I have. So again, I have to look at and I have to think about, okay, which way am I going to go here? Collinear points lie in the same line. Collinear points are happening first, and then they are lying in the same line. So if the points are collinear, then they lie in the same line. That is the correct answer. Now, some people possibly had this written down. If the points lie in the same line, then they are collinear. And I know what you're saying is, hey, this one is true too, Mrs. Hefty, so this counts. But we're talking about first the collinear points are happening, then they are lying in the same plane, is what it says here. So this is not the correct answer. The one above is, if the points are collinear, then they lie in the same line. I added an extra example here. I don't know if you can squeeze it down on the bottom. Let me get that screen up too. Where did that go again? There we go. My screen. If you could squeeze that on the bottom, that would be great. Otherwise, if you turn to the next page, we had a truth table area, and we're not going to do the truth table. So if you could possibly write it in the truth table area in a blank spot, that would be good too. So in number 5, it says, I will follow if you lead. Now, in this situation, just because I will follow comes first, that does not mean that is the hypothesis or the if part. Can you guys see here in this, if you lead, that's going to be the hypothesis. I will follow you is going to be the conclusion. And I did have it written down both ways, so if you're always thinking, hey, the first thing is going to be the if part, and the second thing is going to be the conclusion or the then part, you're not right on that. So you need to be careful when you're reading through your statements here to determine which one is the hypothesis and what is the conclusion. So if you wrote, if I follow, then you lead, that's not correct. You're going to follow if that other person leads. So if you lead first, then I will follow is the correct answer. Again, I spoke about not doing the truth table part of this lesson, so we're going to skip that, and we're going to go down to the bottom, which is converse. And so then at this point, we're going to start changing statements, and one of the changes that we're going to make is called a converse. And converse is exchanging the hypothesis and the conclusion around. So you take the then part and you move it to the front, and you take the if part and you move it to the back. You're just switching those two around. So the directions on your paper say write the converse. I've added some here I forgot to add. Then determine if it is true or false. Give a counterexample if it is false. So take a minute, pause this video, and add that to your directions, please. And so I have one example here. These problems are not as difficult if you have the first statement in if-then form. This problem is not in if-then form. So the first thing you have to do, and I have notes here, and I suggest that you write those down. When you go to write a converse, the first thing you need to do is make sure that you have the hypothesis and the conclusion identified. And so I encourage you to take a minute and write it in if-then form. All right, so now when I read my example here, it says all squares are quadrilaterals. Okay, when I write this as an if-then statement, it needs to be true. My conditional statement needs to be true. So I have two things. I have squares and I have quadrilaterals. If it is a square, then it is a quadrilateral. Or would it read, if it's a quadrilateral, then it's a square. If it's a quadrilateral, then it's a square is not a true statement. So my first one, if it is a square, then it's a quadrilateral, is the correct conditional statement, is the if-then statement. And I believe I have that under here if my eraser will work. Oh, there we go. If it is a quadrilateral, then it is a square. Okay, now I have my conditional statement written. Now the next thing I need to do is make the converse. So the second thing you're going to do is change it to the converse. So the converse says, take the conclusion and move it to the front. So it's going to read, if it's a quadrilateral, take the hypothesis and move it to the back. It is a square. Then it is a square. Okay, so far I have written my converse. This is really what this problem has asked me to do. The next thing it's asking me to do is then determine if it's true or false and give a counter example. So now because I've rearranged things, my conditional statement may be false at this point. So I need to be thinking about this. Is every quadrilateral a square? Every single quadrilateral a square? And at this point you're probably saying, hey, this is false. Now, remember, counterexamples need to be specific examples. So if you're writing a note that not every quadrilateral is a square, you are not going to get credit for your counterexample. You need to give a specific example. So you could say, hey, a rectangle is not a square. Somebody might be writing down right now, a parallelogram is not a square. But again, if you're just writing a vague statement saying quadrilaterals are, not everyone is going to be a square, that will be marked wrong. Counter examples need to be specific examples. Like I said, Tiana is a freshman in geometry. I'm relating this back to that previous lesson where I was talking about sophomores being in geometry. So, you guys have a great night, and I'll see you in class tomorrow.